Ever wondered how your message travels from your phone to someone sitting miles away? The secret is the OSI model, and it's way simpler than you think. So, in today's video, I'm breaking down what is the OSI model and the 7 layers in a way that even absolute beginners can follow. So, what will you learn from this video? Why the OSI model matters in networking, what each layer does from top to bottom, and how these layers help devices communicate smoothly in real life. By the end of this video, the OSI model will finally make sense. No jargons, no confusions. So stick till the end, hit subscribe, and follow Thinkcloudly for more easy tech breakdowns. Let's get started.
The OSI model. So what is basically OSI model? It's an app and it stands for Open System Interconnection. So it was rolled out in 1990s basically as a framework so that we can understand how the internet works, how the internet will work. It was never used for in the production. For the production, we always go through the TCP, Transmission Control Protocol. So that is where that's not only compromise of 4 layers. So it combines basically the 3 layers of OSI into a single layer called application layer. Okay, but why we understand the OSI model is because we can break down the internet. Or we can understand how end-to-end communication is working using the OSI model. When we explain each layer, you will get to know how the internet is working, how we are communicating with each other, what are the types of protocols we are using, where the encryption is using, where the physical security comes in picture, and all that. But if we go through the TCP IP, we will only get 4 layers. That's why, for understanding purpose, we understand it through the OSI so that we can understand depth. But in reality, TCP IP is the model that we use for the production. Okay, start from the bottom. The first layer will be the physical layer. We can understand it either from the top or the bottom. It's fine. We can still reach the conclusion, but the layer 1 is always treated as physical layer if it's from the sender end, and from the receiver's end, it's always the application layer. Okay, so let me start with physical layer. Okay, so physical layer, basically, what does it, or let's start with the application layer. That will be more easy to understand in that way, because you already know about the applications. Like we have Facebook application, we have WhatsApp application, we have Google Chrome, Microsoft Edge, all these browsers, right? So these are basically applications. Now, what's the work of an application? It's basically the end user. Now, who is using the application? It's either you or me or any human being, right? So for us to connect with the network, basically, that's the bits and bytes, that's or the traffic or the data that's being transmitted in the wires or wireless, so that we can interact with it. We have the applications at the first place. Okay, so these are basically the mode of transmission, or we can say that end user application that are used to interact with the network itself. Okay, that's the whole purpose of the application. Now, how so? That's why it says that the end user layer. Why it's the end user layer? Because it helps end user to connect with the network. Okay, that's the purpose of the application layer. We have different protocols we use in the application layer, or a lot of things that's happening in the application layers. The first thing, let's go start with the HTTP and HTTPS. So hypertext transmission service, or some protocol. Yes, hypertext transmission protocol, HTTP. So HTTP was used in the past. It's still being used nowadays as well, but it's unsecure and unreliable. And HTTP use port 80. Now, I'll ask you to remember these things or note it down, because they might be used in the daily investigation and in the interviews as well. So HTTP use some. So we have ports. What are ports? So ports, we have 65,000 plus ports globally standardized, and there are some ports that are standard ports, and there are some ports that are not standard. Standard ports are those ports which are defined for a particular activity. Like when I say port 80, if I mention port 80, it is implicit that I am implying that this is being used by the HTTP. When let's suppose I say port 443, it's implicit that it's being used for HTTPS. When I say, let's suppose port 23, it's used for probably FTP, right? Port 22 for use for SSH, 53 for DNS. So these are some of the known ports, and these are the standard ports that we use. Okay. So when are they used? They are basically used like let's suppose I have to allow some traffic on the firewall. So the firewall team has to configure something on the firewall. He has to mention, let me allow all the HTTPS traffic. Then he has to mention the protocol there. That protocol will be 443. That means all the HTTPS traffic coming from port 443 will be allowed to our organization or will be blocked to our organization. Depends upon the policy that we create. Okay. Now the application layer. It's one of the protocols is HTTP and HTTPS. So what will happen in both the cases? So let's suppose, let me show you here. Let me first move this screen to other one. To my second display. This is some website I've opened. You see, what is this mentioned in the beginning? HTTPS, right? So this gives me a clear message that this particular website, whatever I transmit there, is secure. Why? Because HTTPS use a certificate, SSL certificates or TLS certificates that make sure that there is encryption happening between you and me, between this site and me. When I'm communicating, when I will put some data in here to look for something, let's suppose the IP address, this is a particular tool, I can put the IP address there and I can search for it, right? So I'm putting some sensitive information or my personal information there. I want to make sure that everything is encrypted. Even if the attacker has the access, he cannot decrypt it, he cannot understand what I have put in there. So we have HTTPS, that's why we have HTTPS, the advanced version of HTTP or replacement of HTTP, which is more secure, which use the encryption protocols basically. So that means whenever an end user is communicating to this particular website, it's making sure that this is encrypted in an encrypted way. On the contrary, HTTP doesn't use any encryption method. It simply sends our data in a plain text. That means if I interacted with some site, let's suppose HTTP, only HTTP, not HTTPS, that means it's an unsecure website. Okay, let me just, okay, not happen. So whenever you visit any HTTP site, you will see on the browser, it shows unsecure. Why? Because this is already obsolete and we don't use it, we should not use it because it's not encrypted. That means whenever we communicate with the HTTP sites, whatever data we put in there, it may be easily interpreted by the attacker. Let's suppose there is a man in the middle attack that we studied last week. Okay, so in that case, what will happen? The attacker will have the access to all the information we put on this website, which will breach both the confidentiality and he can tamper the data as well. That will indeed breach the integrity part of the CIA as well that we studied, right? So this type of protocols are happening at application layer of the OSI model. Similarly, we have file transmission protocol here. That means files are transmitted using the encryption method or a secure way at the application level. We have DNS here, we have the SSH. SSH is basically a protocol which is used to connect to a remote service. Let's suppose you have to connect to a virtual machine from this, my machine, I have to connect to a server or any particular Linux machine, right? So I will use SSH. So the previous version of SSH was the Telnet. So Telnet had the same problem. It didn't use the encryption method. Whenever we connected to any machine in the past using Telnet, we were able to connect to remote the session, but it was not secure. So attacker may have breached. He can see our passwords. He can interpret the data that we are sending between each other. Okay, something like that. But then we came up with HTTPS, which is sorry, we came up with SSH, which is more secure and more reliable because it used the encryption methods. Okay, and nowadays we use SSH instead of Telnet. Okay. So at the application level, we have this thing. Then we have the presentation layer. Then now this is what you're seeing on the screen is application, right? But before the application, there's a down it, below it is a presentation layer. Now what does presentation layer does? It does the syntax. It's also known as the syntax layer. Why? Because here everything is basically defined between the sender and receiver. So it ensures that the data is properly in a proper format between the sender and the receiver. When I say that, that means it basically makes all of the use and of the data and ensures that this data is feasible for the receiver. Now, if I'm communicating to you, and at when before it reaches to your application, let's suppose WhatsApp, there is one more layer for it's just a virtual idea you have to create in the imagination, that there is a layer which basically makes sure the data that's coming from my end to you is properly formatted so that it can be understood by the application. Okay, that is
Mhm.
the purpose of this application. Now, what is the function? More functions about this. Now, encryption and decryption of the data happens at this particular layer. So if I am doing the encryption, now I'm sending something, right? Let's suppose I am the user, trying to send you something. So I have the computer physical layer, then we have the network, it went through firewalls, it went to the here, it went to the internet. Okay, now I'm using, let's suppose, TCP here. Then I created a session with you. Now I created a session with you, then my presentation layer, I will do the encryption. Now there are different types of encryption which we have to study in the future module. But for now, let's suppose the encryption means that the data is encrypted. That means data is secure when I transmit it to you. Now I reach to WhatsApp, and WhatsApp send the message to you. Now when you will receive it, before you receive it, the decryption will happen. So at your presentation level layer, it will have a key, whether it's a public key or a private key, depending upon the encryption, but it will have a key, and that key will be only with you, not with anybody else. That's why the data is secure. So you will have the key and it will decrypt the data. You will use the key and it will decrypt the data. That means that's why the presentations layer make sure that data formatting is there and we are able to understand it. Why? Because if the decryption will not happen at the presentation layer, then we will not be able to understand the message. Now, let's suppose I typed in "Hello, John." Now, this is English what I typed in the WhatsApp, but WhatsApp is encrypting the data. Now, what will be in the encryption method, depending upon the formula? Let's say it types something like this. Okay. Now, this is the encryption method that made "Hello, John" look like this. Now, this is encryption. This is the coded message. Even if the attacker has access to our message, he cannot interpret this message that this means "Hello, John." Right? It's almost next to impossible to decrypt 256-bit of encryption. They are decryption tools for 128-bit, 160-bit of encryptions. That's why they are obsolete and are not used. Practically, they are used, but on theory, they should not be used. That's why we have a standard 256-bit of encryption globally accepted and globally used nowadays. And then we have 512-bit of encryption that I believe is mostly used in very high level of projects like military operations and all that. But till now, I have not heard any case on the internet that 256-bit of encryption has been decrypted by any attacker. So we are safe till 256-bit of encryption. Let's suppose we have 256-bit of encryption and "Hello, John" looks like something like this. Now we know that if the attacker has even the message, he sniffed somehow and he got the message, he will not be able to decrypt it. But both the encryption and the decryption process is happening at the presentation layer. Okay. Now when we transmit the message, we also compress the message so that we can reduce the size of the message when we transmit over to the internet. So both the compression and the decompression. So if I'm the sender, then my message will be compressed. And when it will reach you, it need to be decompressed so that it will be in its original format. So both the compression and the decompression of the message is happening at the presentation layer as well. And finally, the data translation. That means what is the format of the message. Now when the message will travel, let's suppose I have to I am sending you a message in a text, I'm sending an audio, and I'm sending you a video. Now all of these three, we know that they have different format. For text, maybe it's .txt format. For voice, it may be MP3, let's suppose, right? It may be wave format in audio, like for the songs you have seen MP3 formats mostly. Then for video, it may be MP4, it may be HD or something like that, any format, other formats, right? But when we transmit the message, when we compress it and transmit, it doesn't uh, send the message in dot MP3 or all that. No, right? It basically encodes it, or it so this particular layer makes sure that whatever the file is, it will be received in a particular format. If it's an image, then it should then it will see in the code itself the message that's been sent. The details are there. Then it will show you whether it's a JPG image, whether it's a PNG image. So it will convert to it that format. If it's a video, it will show if it's an MP4 format. If it's in any other format, then it will convert to that format. If it's any other format, then it will convert to that format. So three main functions for this layer is that encryption and decryption happens at presentation layer, and compression and compression and decompression happens at this particular layer, and the data translation, that means what is the format of the message, happens at this particular layer. Okay. Now, what are the protocols for this? Protocols can be the JPEG, it can be PNG, it can be MP4, it can be TLS, SSL. Now, what's TLS? SSL was used in HTTPS. So HTTPS works on some protocol, on encryption protocol. When I said that HTTPS use encryption method, I meant from the backend, there's some certificate that has been generated from the backend, right? So initially we used SSL, but nowadays SSL is obsolete. Why? Because it doesn't provide enough encryption that we can say it's safe. Then we had it being replaced by TLS. Now TLS, there was version 1, 1.1, both of them were obsolete because again, the encryption, we had to, each passing day, we had to increase the encryption because there are more sophisticated attacks. So the current is 1.2 and 1.3, TLS 1.2, 1.3. So both are acceptable and both are the modern form of encryption over the HTTPS. So these are the, what you can say, the protocols of this layer. JPEG, MP3, MP4, TLS, SSL. These are the protocols for the presentation layer. Okay. Okay. So now I was saying about the session layer. As the name indicates, it creates a session. So now let's suppose you and me are communicating on the Google Meet. Now Google Meet is the application. But on the back end, there's a presentation layer, which is basically making sure that the data formatting is correct. We have the proper encryption and decryption method happening. But below it is another layer, which is called session layer. Now, what the session layer does, it basically is responsible to create the session between you and me, live session. So I'm sending you a request, like let's suppose a message. I sent you a message and you received it. Now you acknowledged it that I received the message, and then you type something, you send it back to me, I send it back to you. So there's a two-way communication continuously happening. So it's not necessarily that there will be only one session created between you and me. There can be multiple sessions created between you and me. Now, what is the function of this layer? To start, to manage, and end the sessions. So this layer is particularly responsible that it will start a session between you and me. It's managing our session, and it's ending our session as well. So you remember the AAA that we studied about the authentication, authorization, and all that. So authentication and authorization is happening authenticated, where this is the particular receiver that's intended to receive the data. So it's making sure that authentication and authorization is happening here. Okay. Now, if there is a glitch between the sessions that happened just right now, so I had a session with you, and because the internet went down, so now the session layer is responsible to resume this session as well. Okay, it will continuously try to request the information. Okay, I just had a glitch. I'll just try to see. It will show you the reconnecting session, like this. That I'll try to continuously, expand the session. There is some timeout. Once the timeout is done, it will close the session. Okay, properly the host is not responding, I'll close the session. But if it will have some time until it will close the session. Until then, it will try to continuously make the session out. Okay. Protocols for this is NetBIOS. We have API sockets for it. Or API calls. So basically API calls is basically used. Now again, this is core infrastructure concept about the API or even in the security used for automations mostly. So the API is basically, let's suppose you're working on a virtual machine. You have a virtual machine, you're the admin of it, and there's another guy who has to work on this virtual machine as well. Okay, but you have to give him the access so that he can log into the server and then he can work on it. But you don't want him to explore the whole this server, what is in there. He just need a particular set of data there. That's it. He doesn't need all of it because because there are a lot of configurations of the server. Let's suppose it's an Active Directory server. There are a lot of all of the Active Directory configurations there. But he has to work on a particular project under the Active Directory. Now we create the APIs. Okay, and now when we create the APIs, now we can give access, or this particular user can call this API and he will get only specific access about that particular resource, not the entire server. Okay, that's where the API calls are basically used, and these are the protocols of or components of this particular layer. Okay, now comes the transport layer. Now this is the basically where our data is moving around. Okay, now I'm connecting to you, sitting in the US, I'm sitting in the India. Now this is the data that's we are continuously exchanging. This is happening at the transport layer, so it makes sure that there is an end-to-end communication between of the data. That means end-to-end transport of the data, and it's reliable. That means when I say reliable, that means we can trust the data that has been sent. Okay, and now what are the functions of this layer? This was just a theory. Now what are the function of this layer? So function of this layer is that it will check the error detection and error correction. When we receive a message, it has a formula. It will check sums from the back end. So this is a mathematical formula on the theoretical part that's happening, and it use this formula to make sure that the data that's being sent has not been lost. Okay, so it will perform the checksum. If something is lost, it will again re-ask that to resend this data. If it will fail the checksum, for example, or if it will detect some error. Okay, it's basically a whole subject called data communication networking. I mean, if we have to go in detail about it, but just to give you an idea that there are a lot of checksums happening from the backend, and it makes sure that there is no error happening between the communication, and the data is flowing properly with a proper speed, managing the speed and all of it. Okay, the protocols for this session layer is TCP and UDP. Now this is really important because TCP, this is the interview question as well, to make a difference between the TCP and UDP, and what are the applications of TCP and UDP. Now this protocol defines which mode of communication I have to use, whether I have to use TCP or I have to use UDP. What's TCP? TCP is a protocol, and it is more reliable, and it's connection oriented. That means if the data is being sent through the TCP mode, it will be more secure. It will be a little bit slow. When I say slow, I mean in contrary or in contrast to the UDP. So UDP is fast, but it's not reliable. It's unreliable. Okay, TCP is a little bit slow compared to UDP, but it's reliable. Okay, when I say reliable, that means the data is secure. That means the applications for it is like Google Teams we are having, it will be on TCP, not on UDP probably. Or the WhatsApp chats that we have, it's on TCP. So whenever we need a secure communication, we will use the TCP mode of communication at the transport layer. And whenever we need to send something very fast, we will be using UDP. The application for UDP is live streaming. Like there's a match happening, football match, cricket match, or any match, we're live streaming it. We need speed because we have a lot of users, right? A lot of users that are basically watching it live, and we need speed for that. So we are using the UDP connection for that. The another application for the UDP will be gaming, whether it's live gaming or it's connecting to the server. It's using the internet. So we want to make sure that there is no lagging in the gaming. Like I have heard, I don't know if you have heard about PUBG. A lot of people use PUBG, right? So this is again, they have to connect all the time. They have to connect every time with the users and all that, so that there will be no lagging and all that. So I guess the UDP connection will be used at that particular mode. Okay. Now comes the network layer. So network layer is, I believe, very important. This is specifically for the networking team and the security team. But from the cybersecurity perspective, we should also understand it, not in terms of protocols. We don't have to do anything with these protocols. I'll explain the protocols, but we just have to understand the logic behind it. So this is basically, networking is where the IP address is assigned. Now, there are two types of address that we have. One is the physical address of a device, which is also known as MAC address. Okay, and it's unique globally. So every machine, it's interesting, every machine that's produced, whether it's computers, laptops, any IoT device that's connected to internet, has a unique MAC address. Now that's also known as the physical address. Now another one is the virtual address. Virtual address is also known as IP address. Why it's virtual address? Because it is not unique. IP address may not be unique. Like I explained, we have static IPs, we have dynamic IPs. So let's suppose that static IPs in some way are unique. Why? Because they are assigned to a particular domain. But dynamic IPs are the most one that are used globally, and they are not unique. Today it can be with me, tomorrow it can be with you. So, but the IP address is used, public IP address is used to communicate with other device or other communication. If there is no IP, we cannot communicate. So if I'm receiving a traffic, let's suppose, there will be an IP address assigned to it as well. Attacker may hide this, may mask this IP address so that we cannot see it, but it still have the IP address from the backend. Okay, without the public IP, there can be no communication. So everything that's connecting on the internet will have public IP, and these public IP will help us communicate. So now networking layer main function is to route the data that we have sent. So I type the data, it went to the computer keyboards, it made a proper message. Now it made it in the 0-1 binary format. Now this will travel, let's suppose, wirelessly or through the wired if I have a LAN connection, and eventually it will travel to the router. Now router is a device which is basically responsible to route the traffic. That means it will decide on its protocol which path it will travel to reach the destination. That's the main aim of the router. Okay, we have to understand the router as well in this module itself. What's a router? I'm explaining it now. So the router is a device which basically helps us to route the traffic. It will whatever the protocols has been configured by the network security team or the network team on it, it will then explain, or it will then decide the route of this packet. In our world, I can simply say that I want to travel, let's suppose, to Germany. Now I have one way going through the Central Asia, through Uzbekistan, Russia, and all that, and then I will go to reach Germany. But then I have another route which is going to the Middle East from Arab countries, and then eventually to the European countries, and then I will reach Germany. Now these two routes are different protocols. It depends what protocol we have used. If we want speed, then we have different protocol. If we want secure, let's suppose secure on a unique path, then we have different protocols for that. Okay, depending on the protocol, router will define what route it will take. So this layer basically helps us to handle the routing and giving the IP address across the network, assigning the IP address across the network. Now, if I have an organization with 5,000 employees and they want to connect to internet, now we have some public IP that's been configured at the firewall or at the router, and that public IP will be sending the traffic out to the internet, and that's happening on the network layer. Okay, that's why the device used at the network layer are routers and firewalls. Okay, the devices that are used at network layer are VPNs. Mostly we say routers and firewall, but VPN can be also in some cases included in the network layer, because that also determines the path. Now, if we are using the VPN to make sure that the whole traffic on the internet is going encrypted, then we use VPN for that, right? So that can be also counted in the network layer. Okay. Now, what is the protocol for it? Protocol will be IP. Now we have two types of IP, IPv6 and IPv4. Nowadays, we're using the IPv6 as well, because IPv4 is almost being exhausted. We have limited address there and it's being exhausted. So the protocols for this will be IP address, both IPv4, IPv6, and then we have protocols like routing protocols like RIP, BGP, OSPF, so open source, open short path first. That means if you have to travel fastly, then probably you can use OSPF. Similarly, these are the protocols, and it has nothing to do with the cybersecurity. That's what the network team will configure, and we will never get to know what protocols have been used. Even in any organization that I have worked, I don't know what protocols they have used because it's none of my business what they're doing, right? I just need to monitor the traffic that's coming from the firewall to my SIM platform, and I need to analyze the traffic, what's happening, right? Next layer will be the data link layer. Now, the data link layer is again responsible for the communication. It's not responsible for the WAN communication. That means wide area network. That means the internet. It's responsible for the LAN area network, LAN, LAN, or we call it local area network. It's responsible basically to make the communication between node to node. Now, let's understand this part using diagram. Okay. Let's say we have an organization and this is the structure. This is the firewall, okay? This is, let's say, the router. And let's say these are our users with the end machines or laptops, computers, whatever you wanna say. And this is our switch here. Now, these, in an ideal case, for understanding, now this is a switch. Switch is basically used to connect the devices within the network. Now this is our network, right? And I will create another dash here. And outside this line is internet. This is our internal network, or we call it LAN, okay? So this particular user now wants to connect to internet. So first they are connected to this particular switch, okay? So without internet, these devices, these 4 devices can communicate with each other as well. Why? Because we don't need internet for them to connect. They are in our internal network, they are in the LAN network, and the switch will help them to communicate with each other. Let's suppose this will give a message ping to this, and it will say I have to reach out to host. This is host number 1, this is host number 4. It will say I have to reach out to host number 4. Once it will transfer the message to switch. Switch is an intelligent device. It will see which all devices are connected on my list. So it has a list that is saved in the configuration, and it will know which all hosts are connected on me. It will search first itself within the list whether he's trying to reach outside the internet or within our organization. If you'll see that he's trying to reach out to host number 4, then we don't need internet. It will simply route the traffic to this port, and this port will give the message to this particular host. Okay. Now this is something called node communication. Okay. Now this switch at the end is connected to router, and router is connected to eventually firewall, and here all the networking is done here and here. So we decide the protocols here, which traffic route it will flow, and eventually the firewall's work is that whatever router is sending outside, it will check the policies, whether this traffic is supposed to go outside or not, or whether the traffic that's coming from the outside, whether it's intended to be in our organization or not. If it's not, it will block it here. If it's intended, then obviously it will travel. Okay. It will travel to the router, and router will indeed forward it to the switch, and switch will then see where the message has to be delivered, whether it was requested by this user or this user. So this particular layer, data link layer, make sure that node to node communication is happening within the LAN. So this particular section is now LAN. So the communication from this laptop or from this machine to router, we can say that this is the part of the data link layer. Okay. Now, what are the protocols that we have here? We have Wi-Fi. We have Ethernet cables, physical cables that we connect to the laptop, right? Or we have the wireless connections, because now I have connected through the Wi-Fi as well. This is the protocol for this data link layer, right? Why? Because this Wi-Fi is making sure that my message is being first transmitted internally. Like, let's suppose I'm the user here and I have connected the Wi-Fi to the internet, but first my message will not directly go to the router, the main router, not the home router. It will first go and see whether I want to communicate. If I have communicated another laptop here, whether I want to switch there. So the internet traffic will be something like this. The internal organization structure will be something like this. Okay. So it makes sure that there's an end-to-end communication within the node. Okay. What's the protocol for this? The protocol for this MAC address as well. We have Wi-Fi. We have, like I said, Ethernet. So Now, what's MAC address? MAC address, I said, is a physical address that's assigned to this particular device, so that we will come to know which vendor it belongs to, what is the device functionality, and all that. Okay, so the MAC address is so this now why is the MAC address used in this particular data link layer? I'll give you an example here. Now, let's suppose I just took 4 devices here, right? We obviously have hundreds and thousands of device users and machines in an organization, correct? So let's suppose, how do switch remembers them? Today's this computer name may be host 1, but if I have the admin level of access, I can change to the host number 2, right? I can change it, or admin can change it any time. That my point is that host name or any other configuration is not static. It's variable. It can change. But like I said, MAC address is unique. It has its unique value. It will not change irrespective of anything globally. So that means this particular laptop has a unique MAC address. This has a unique MAC address. This is a unique MAC address. This is a unique MAC address. Now this switch will, whatever device will connect to this switch, it will automatically update its table. So this particular switch will remember these devices based on the MAC address. So it will remember that on port 1, this particular MAC address is connected. That means it will remember that this MAC belongs to this device, this MAC belongs to this device, this MAC belongs to this device, this MAC belongs to this device. So all of this is happening at data link layer. Okay, and eventually the physical layer. What is the physical layer? Physical layer is nothing, but it's more simple to understand. It's the physical structure. That means the power cables, the repeaters. Maybe we use repeaters because after every, so you know that when we transmit the message, it's in high voltage or low voltage. That means 0 or 1, right? And this message, after some time, lose its intensity or energy in a way, and we use repeaters at some particular point so that they can enhance this message. They can give it kind of they can give it again the voltage, and it will be again, you know, in proper format, so that we don't lose the message. So repeaters, wireless connection, optical fibers, power connections, all the physical structure that is there is everything in the physical layer. Okay, coax cable is basically for the power cables and all that. Okay, so this is the end-to-end OSI model.